Alright, welcome to my newest LeetCode video where I pick a random LeetCode and just go through the process in solving it that I would in a real interview. Yeah, that's all there really is to say about that one. Let's start off with an easy today, maybe just to warm things up. So I just pick a random one and seeing it for the very first time, I'll try to solve it. So let's get this timer ready and start the timer and start reading. So we're given an array of string called words and we want to return all strings in words that is a substring of another word. Okay, you can return the answer in any order. So let me just write that down. Given an array of strings, words, I'm guessing that means we want to all strings in words. String of another word. Order. Straight away, this sounds a bit tricky. Let's go look at some of these examples. So in words is mass as hero and superhero. Return hero, return as and hero. As is a substring of mass and hero is a substring of superhero. In the second example, we get LeetCode, et, and code. So we should return et and code as the both substrings of LeetCode. The third one, we've got green. We've got blue, green, and boo. We don't return anything because there's no substrings in there. And our constraints. Each word can be, not each word. We can have 100 words in our word array, and each word can be up to 30 characters long. And each word only contains lowercase English letters, and each word is unique. For an easy question, this looks a bit scary to me. So what can we think of? Even just a brute force approach. It's a bit scary. I don't know. I'll just write down anything I can sort of think of. We could just go word by word. Generate word by word and check if it's a substring of any other word in the array. Now that is pretty inefficient. Just for comparing, that would be bigger of n squared. But now to check if it's a substring, how would we do that? Just a sliding window, maybe? To check if a word is a substring of another, use a sliding window, and keep that. I don't know if that's the best way, but so that would be what, big O of the size of the larger word, take the size of the shorter word to compare them, which is a complicated time complexity issue. So this is a bit tricky. Let's just write that down. Time complexity of word by word is bigger than n squared. Checking if a word is a substring would be, bigger x take y, I think, where x is the length of the longer word and y the length of the shorter word. Okay, so we've got that brute force approach, which should work, but it's probably much too inefficient and unnecessary. So what else can we think of? So there's only 100 words in the array. So I mean, an n squared approach is nowhere near too slow, but I think we should still think of improved ways. Well, let me just write down my thoughts as I speak. So there's no point comparing longer words to shorter words. As in, there's no point checking if a longer word is a substring of a shorter word because it just won't be. That's not how it works. It's too long. So that begs the question: can we sort something first? Can we sort the what could we do that? I was gonna say, could we sort words? Sort the array of words by their size, but I'm not sure how we can do that. I'll write that down there. Could we sort words by their size? Not sure how we would do that, what sort of operation we could call there. But that's just an idea. I mean, maybe, but I'm not sure. Let me think about it a bit more, otherwise I might try to implement that brute force approach and then see if we can shorten or improve our efficiency anywhere. Not really sure. Well, I guess I can't really think of anything, so we'll start implementing our brute force, and I'll also just mention that the space complexity is constant auxiliary space, but of course you need the space for the substring words, so you don't need to do anything extra. I mean, big of one auxiliary space, is that how you spell it? Hopefully that's close enough. Result and this of substring words. So let's try implementing the brute force. So we need to initialize our variables and result, and then iterate through words, sort of twice nested, comparing each one. If words I is a substring of words j, set it to the result, and then just result. So we'll also just need a function to check if a word is a substring of another. That'll just make it a lot easier, I reckon, and make the code a lot more readable and modular, which is always good in an interview to show off. So what could we do? We could also return a boolean. We'll just call it is substring, and it takes in 2 words, word 1 and word 2. That's it. Straight away we need to make sure that the word we're comparing is the right size, as in not too long. So return false straight away if we'll say word 1 is the potential substring. Word 1 size is greater than word 2 size. And if it's equal as well, because if they are equal sized, then they're not the same because each word is unique. So we can do that. So we can just do if copy that comment straight out. If the size of word 1 is greater than or equal to the size of word 2, we just can simply return false. Otherwise, we need to sort of, how could we do this? Sliding window is my first thought. I'm not sure if there's a better way. Substring, so we want our left point at 0 and right at word1 dot size. So take 1. Yeah, size take 1. And then we just do while right is not out of bounds of word 2. We need to, I'm not sure what the best way to do it is, but what we can do is just make a temporary copy of the window we're at on word 2. So put that temp, and if I recall correctly, I think it's something like doing this. So word 2 dot substring. I could be wrong. I'll double check if it's wrong after. I remember it being something like this. And so it starts at L, and as far as I know, so the first parameter is the position we're starting at, and the second is the number of elements. I could be wrong, but we'll just go for this for now. So that would be take L elements long, if I recall correctly. Yeah. And then we'll just do if word1 equals temp, we would return true. And then after checking that, if word1 doesn't equal temp, we would just increment each one. And if we get to the end and we haven't come across a matching substring, we return false. Well, let's add some comments. Pointers, temporary string of the window, and then we just want to compare word1 to matching returns true. That's self-explanatory. So back to our main function, we want to initialize our variables and result. Are there any other variables we need to worry about? I think it's just the result vector. So let's get that res, and then we want to iterate through words twice nested. So we can just do I equals 0, I is less than words size I plus plus. And then sort of the same thing, but with a new iterator. We can put J. Move this comment in here just for readability. And now what we will do is we will just check that if is substring words I words J, we would push back words I to the result. Words I. And that should be good as far as I'm aware. And then we just want to res. Now hopefully this works. I may have made some mistakes in this part, especially that substring part. But let's run it and just see how we get on. Not good. So seems we return nothing every time. So I'm guessing there's something wrong in this part. Let me just Google how. Well, I can either Google it or do some print testing. Let's just do some print testing before we Google it, just to see what we've been getting as our temporary string there. so there should never be three, a thing of three anyway. So is it R take L plus 1 or take 1? Yes, yeah, it's plus 1. Plus 1, because if they're both at 0, that means the other string is still one element long, so you get a plus 1. And now that works. Let's just remove the print and let's submit it, and hopefully that's good at 15 minutes. Not good. Of course, it does the first 6, the first test cases, but where did we mess up? At this one. So we mess up here. We output odd twice for some reason. Why do we do that? Let's see. That's weird. I would have thought. I don't see why that would happen at the moment. Let's just double check the iterators. That means it has compared odd to it's compared odd to something, and then so it's found odd in LeetCoder, and it's moved on to LeetCode, and it's found it in there as well, so it's been added there as well. So I guess in that case, I guess we could just iterate I, maybe. I'm not sure if that would work, or we would have to double check that word's I is not really there. I think that should work though. Pretty confident that just iterating I there would work. No, I guess you're not allowed to do that. I'm just trying to think, because as soon as we find one, we want to go skip to the next I and not keep going down the J's. I guess we could use a another variable, maybe just a tracker, I guess. I mean, I don't know if it's the best way, but we can use it for now. So if we just set a boolean found, and it starts at false before we check any, and then once we find one, we set found equals true. Then after this, we will just go, or do we just break? Do we just I mean continue there? Would that just would that continue to the right place? It's just the only thing I'm worried about. Let's just test it. No, it is the same thing. I was hoping that continue there would continue to the next thing, but I guess it continues to the next J. Just out of curiosity, what happens if we do break? Does that break it out of everything? Ooh, maybe that's what we want. Break breaks out of the for loop. Maybe. Okay, good. We've got a solution. And yeah, as I said, not probably the optimal solution here. Big O of n squared plus or times the checking, which is another thing. But it is an acceptable solution, which is good. I'll just write down what time we got the best in. Not the best. Oops. An acceptable. Why have I forgotten how to spell acceptable? Acceptable solution in. Just so I remember, I know it's down here, but I don't want to forget. So, I mean, if anyone's watching, if they can think of anything that would be better, do let me know. Otherwise, I'll think about it for a little bit, and then we'll look at the solutions. So, the only thing I can think of is sorting words by word size first, which I'm not quite sure how to do, because that would need a custom comparator function, I believe. I mean, I'll try it, or at least try to work out what it would be. Sort words by length. So we could sort words from the start to the end, and then I don't remember quite. Can't if you just do that, or if it's a const. I just remember seeing some of these, or maybe it was that first, or maybe it was that first. Don't remember. I'll do what I remember, and then I'll Google it, just for practice. So I know it needs the two things we're comparing. B, and then I guess we would just return a size. Size, and that should return it. So I think the smaller one should be first. I'm not sure I've done this part right. Let's see what error we get, and then I'll just Google it because it's not the end of the world. There. Yeah, I've done it wrong. That on the official. I'm not sure if it's official, but a reference set. What do we need? Is it a void? No, just the compare that we need. It's a function. How do we kind of do the function? Oops. I remember seeing those double brackets somewhere. Where? Does that work? Or do we need a name, or is that a boolean? It says order is not allowed. Just call it compare for now. I'm just doing some trial and error. Let's look at this again. It's my function, and that's how my function looks there. So I might ask Mr. ChatGPT. Yeah, because it's usually pretty good at this. So I want to write a custom store function in C++. This should give us some help. Yep, so we've used these sort of thingy. Oh, should we do it? I know you can do it in the same line, so maybe it's better to do it outside. Which I mean, I'll try that. See what's wrong with that. Oops, so what do we get now? Oh, yeah. Of course. Let's see what we get. Compare. Yeah, what do I call compare with? Nothing. Maybe I need to say it's a string. Say these are strings, maybe. Otherwise, I'm not sure. Reference to non-static. What does that mean? What am I missing? Nothing as far as I can tell. Boolean, we just call it compare. It takes in a constant string by reference A and B, and returns. Thinking, oh, it also says to change that. I'll change it for now. Okay, I'm a bit confused why this isn't working. Let me just plug it into ChatGPT. Error. That. Oh, is that what I'm missing? That little tidbit, maybe. Well, and that too. ChatGPT might be messing up on me here, which is not good. So let's Google it again. Custom comparator. Let's see if this is more. Lots of structs. I don't think you need to do the whole struct. This is what I want. So it's just that. Is that what I need? It's the double square brackets, constant thingy, return that. Hopefully that's all we need. Let's run that, see what we get. Alright, we get something sorting it. And then just what do we do with the sorting? We want to quit out early if the length is the same. Or do we even have to do that? Or do we start J from I plus 1? I think that we do, because we can't compare. Can't see if word I is a substring of word J if word I is longer than J. So hopefully this speeds us up a bit. Let's submit that and just see what our runtime is looking like. It's a little bit faster, not great there. So I'm sure there's some more improvements to be made. Also our memory uses quite a bit more. Best solution. I'm guessing that's for this part. That kind of messes us up. I think that should automatically delete temp after each iteration though, as far as I'm aware. So what is our issue before I just look at the solution? I can think about it. If anyone's in chat and wants to give an idea, I'm more than happy for that. I've got one viewer apparently. That could just be a bot, or it could be someone just hanging out. But what else could we do? Maybe it's checking a substring. Maybe there's a more efficient way of doing that. I mean, there's a lot of different methods for substrings. I'm not sure. Just out of curiosity, would this work if I just do that? I'm just going to test that just in case it works. It does work. Does that make it faster and use less space, I wonder? No, I don't think it would. What could we do? I'm sure it's somewhere here that we could find a better place, better implementation. I'm not sure. We spent a bit of time on this, so I'm just going to look at the solutions and see what I've been missing. Whoa, that's a lot. Simpler. So just iterate through words twice. If they're the same, continue. Find what? Can you just do find to find a substring? Hold on. Let me implement that. Can you really just do that? My mind will have been blown if you... I mean, in the root interview, I reckon my approach is still pretty good, since it's just the find function that I missed out, I think. The rest should be alright. See, that's a lot quicker already. And then... So we don't have to sort it, apparently. Not sure... Well, I'll keep the sort function there, and I'll remove it last, just to compare the differences. So we don't even need this whole function if that's all we need. Wow, that's impressive. I didn't know we could do that. So we just change this to the range based thingy. Oops. In words. No, it's a string, so we don't actually need to use auto. I guess we could, but we don't need to, so I won't bother. If in J we find I, so that's where I comment continue. Would that work? That should work. Yeah, and then we can also double check that they're not the same word that we're comparing it to. We don't return true. We push back I to results. That's all we need, and then break as well. Almost forgot again. Otherwise, we'll get duplicates. So let's run that and just see what happens. Alright, looks good. Actually just return and remove this stuff. I'm keeping the sort thing because I want to see the difference in run times and stuff if we do and don't sort it. Even though doing this like that might not be the best. I'm just doing some experimenting. But so without the sorting, with the sorting it takes 10 milliseconds and uses 12 megabytes. Without it, it takes 7. I'm curious if we sort it and actually just do this again. Just so we're not doubling up on our comparisons. Let's do that's 1. And then we don't need that again. Just to see what happens. I'm curious. Of course, it's not for J and I. It is words. J and I. I'd just like to know what happens here. Is that any faster? Because n log n will not increase it. I'm not sure how trustworthy 1 millisecond of increase is. We'll look at some other solutions. See if there's any more efficient approaches. Suffix tree, that just looks terrifying and overly complicated. I don't really want to look at that. This is C++. That's just too simple. I prefer C++. Here we go. Alright. I'm not sure why that would be 98% and not any of the other ones. I don't know. So they've got the same results. They iterate through I and J again. If they're not the same, we want to do some checking. No, see, that's not much. Shouldn't be any quicker, as far as I can tell. I guess it's just a coincidence, maybe. To me, I think with bigger inputs, that sorting would make a difference, because Without it, it's big O of n squared, just comparing them. With it, it's still big O of n squared, but it is slightly better because we're not sort of doubling up on our comparisons. We're not comparing unnecessary ones like longer strings to shorter ones when we don't need to. So I'm not sure. Yeah, so we need KMP algorithms. Ooh, I don't know. Let's check Wikipedia. Right. Algorithm by employing situation that when a mismatch occurs, the word itself. So it's just a more efficient checking, which I assume the underlining find would use a pretty efficient way. Alrighty. Yeah, I guess that's sort of hidden, but sure. Okay, maybe with KMP might be better. Has anyone got a specifically explained KMP solution? Just have a look. Doesn't look like it. Alright, well, I'm happy with this. We'll move on to the next one. Thank you for watching this video. If you enjoyed it, be sure to leave a like and subscribe, and leave some feedback. And I'll catch you in the next one.